All right, so when dealing with depth first sort, we could start from any point really, but the way I learned it was to start from the lowest numerical value. So I would start here at the point 0 and give it a discovery time of 1, and then move on to the next lowest value, which is 1. Well, the next lowest value that it's connected to, so either being 1, 3, or 8, and I would pick 1 and give it a discovery time of 2, and do the same thing with this is the only thing that 1 is connected to, so I have to go to 7, and I have to give that a discovery time of 3. And same thing over here, it's only connected to 2, so I have to come directly to this point and give it a discovery time of 4. Then I go to the next lowest value, which would be 3 over 5, so then we give that a discovery time of 5. We've already been to point 0, so we go to point 4 and give it a discovery time of 6, and then we move on to the only available point and give that a discovery time of 7. And once we get here, we realize we've already been to these 2 points. So we give this a completion time of 8, and then we start backtracking. Give this a completion time of 9. Give this a completion time of 10. And when we get to this point, we have to realize that this still has points that we haven't visited yet. So once we come here, we're gonna visit this next point and give it a discovery time of 11, and then visit this point and give it a discovery time of 12, okay? And then once we get here, we give this a completion time of 13, backtrack, give it a completion time of 14, backtrack, give that value that we got to, that we weren't finished with yet, and now that it's finished, we give that a completion time of 15, move on to the 7, give that a completion time of 16, move on to the value 1 and give that a completion time of 17, and finish with the value 0 and give that a completion time of 18. So that's basically how you do the depth first search. The time complexity on that would be big O parentheses V plus E, which is the vertices plus the edges.